All right, numbers 28 to 40. We're on sequences and series. I'm going to start off by writing some formulas for you. You ready? We have f of n is equal to f of n minus 1 plus d. Does anyone know what that one is?
No. Oh, I remember that.
Arithmetic recursive. Anytime you have the f of n minus 1, it's recursive. Next one I'm going to do is, let's see, hang on. Writing them off as f of n is equal to f of n minus 1 times r. Anyone know what that one is? Geometric recursive. Okay. Next one. F of n is equal to f of 1 plus plus d times n minus 1. That one is arithmetic explicit. Sounding familiar at all? F of n is equal to f of 1 times r to the n minus 1. That is your geometric explicit. So we have recursive, we have explicit, and then we have a couple of sum formulas. S of n is equal to, you ready? F of 1 times, actually, you know what, let me do the other one first. N times f of 1 plus f of n all over 2. That is the sum of an arithmetic series, of a finite arithmetic series. And then our other S of n is f of 1 times 1 minus r to the n over 1 minus r. That is the sum of finite geometric. So these are our sum formulas. I would abso-stinkin-lutely write those on your note card. Unless you naturally have them all memorized.
No.
Exactly. Okay? So, as you're writing those down, I'm going to start off with number 28. Number 28 says find the 52nd term and explicit formula. So I know the explicit formula is going to be one of these two guys. The problem they give me is negative 30, comma, negative 36, comma, negative 42, comma, negative 48, comma, dot, dot, dot. First thing I need to know is that arithmetic or geometric. How do I know? Arithmetic, they would be adding or subtracting the same thing each time, which means we have arithmetic explicit. So I have my f of n equals f of 1 plus d times n minus 1. That's the formula I'm using. Yes? What is f of 1? That's the first term, which in this case is negative 30, plus my d value. What's my d value? Negative 6 times n minus 1. You will not see any answers left like this. I'm going to cover up those formulas now so I can scoot it up. You will have to do negative 30 minus 6n plus 6 and then combine your like terms. Let's see, negative 6n minus 24, yes? Or you may see it written as negative 24 minus 6n. Now I have to find the 52nd term, so f of 52 is going to equal negative 6 times 52 minus 24. Let's see. Negative 6 times 52 minus 24 is negative 336. So that's the second part of that answer. Questions over that guy? Where did I get what? The problem asked me. The problem said 28. Find the 52nd term and the explicit formula. So I found the explicit formula first so that the 52nd term is easier to find. Okay? Number 29. It says, given a term in an arithmetic sequence and the common difference, so they're telling me f of 12 equals negative 67, and then d equals negative 4. So that's what they give me. It says, given the term in the arithmetic sequence and the difference, find the 52nd term in the explicit formula. So again, I need to find f of n, and I need to find f of 52. Yes? In the directions, it did say that we were talking about arithmetic. So I'm going to use that same formula from up here, the arithmetic one. F of n is equal to f of 1 plus, they give me my d value, right? The d value is negative 4, so I'm going to write minus 4 times n minus 1. How do I find the first term? I have to plug in what they give me here. Negative 67 is going to get plugged in over here. Because negative 67 is the result you get when n equals 12. So you're plugging in 12 for n and negative 67 over there. So let's see what I've got. Negative 67 equals f of 1 minus 4 times 11 equals f of 1 minus 44. I'm going to add 44. So what does f of 1 equal? Negative 67 plus 44. Negative 23 is my first term. So now that I have f of 1, how do I come up with f of n? F of n is equal to, coming back here, the first term, which I now know is negative 23, minus 4 times n minus 1. Uh-huh. So I have negative 23 minus 4n plus 4, right? Because you got to distribute. So f of n equals, let's see, negative 4n minus 19. There's my answer. And then I also have to find the 52nd term, so f of 52 would be plugging 52 in here. So negative 4 times 52 minus 19. Negative 4 times 52 minus 19 is negative 227. Okay. Questions there on 29? Awesome. All right, ready for number 30?
Nope.
Next page. Number 30 says, given two terms in an arithmetic sequence, find the explicit formula. And they give me two terms. So let me write down those two terms. I have f of 18 equals 17.1 and f of 32 is equal to 19.9. So this time they don't give me the d value or anything. They do give me decimals though, so that tells me that my answer can have decimals. And if you remember, each of these is representing a point. Remember 18, 17.1 and 32, 19.9. So how can I find my d value? I take my y2 minus y1 over x2 minus x1. Another formula you may want to put on your sheet if you have room. So I'm going to do 19.9 minus 17.1 divided by 32 minus 18, and that's going to give me my d value. So 19.9 minus 17.1 is 2.8. 32 minus 18 is 14, and 2.8 divided by 14 is 0.2. So my d value is equal to 0.2. What else do I need to write the formula? I need f of 1. So just like I did in the last problem, where I plugged in the information from one of the points to find f of 1, that's what I'm going to have to do here. So let's see, I'm going to plug in this point because it's smaller. So here's my formula. F of n equals f of 1 plus my d value, which is 0.2, times n minus 1, and I'm going to plug in this first point. So 17.1 equals f of 1 plus 0.2 times 18 minus 1. So 17.1 equals f of 1 plus 0.2 times 17. Zero 0.2 times 17, 3.4. So I subtract 3.4, and I have f of 1 equals 17.1 minus 3.4, 13.7. So now that I have f of 1 and I have d, I can finally write my equation. F of n is equal to, coming back up to here, f of 1, which is 13.7, plus 0.2 times n minus 1, do my distributive property, equals 13.7 plus 0.2n minus 0.2. And finally, my final answer, f of n equals 13.5 plus 0.2n. Or you could say 0.2n plus 13.5. Either way. I know, that one's a lot of work. Okay? So? 31. It says find the 8th term and the explicit formula. So I need to find f of 8 and I need to find f of n. The formula that's given to me is 3, negative 9, 27, negative 81. Now, I know right off the bat this is not arithmetic because arithmetic sequences can never flip from positive, negative, positive, negative, positive, negative. If it goes from positive to negative, it's going to stay in the negative. It's not going to go back and forth. So, I'm pretty sure this is geometric. How do I determine if it's geometric officially? Take the second term, divide it by the first term, reduce. Take the third term, divide it by the second term, reduce. And I should get the same thing no matter which term I take. If I divide it by the term right in front of it, I should get the same thing every time. And the same thing being negative 3, that happens to be my R value of negative 3. I have a geometric sequence. I'm looking for the explicit formula, so that would be this one right here. f of 1 times r to the n. So let's see, f of n is equal to the first term. What's the first term? Times r to the n minus 1. So I have f of n equals 3. And then what is my r value? Negative 3. The n minus 1. That is my explicit formula. Much quicker to get to that explicit formula in geometric ones than in arithmetic ones. It looks like it says n minus 11. That's n minus 1, just to be clear. It also asks me to find f of 8. So if I plug 8 in here, that's going to give me f of 8 equals 3 times negative 3 to the 7th. Now question, do I multiply 3 times negative 3 first, or do I do negative 3 to the 7th first? Negative 3 to the 7th first. Okay, so f of 8 is equal to 3 times negative 3 to the 7th. If I type it in straight like that, my calculator will be good to go. Negative 6561 is my answer for f of 8. Okay, questions there? All right, 32. 32, I also need to find f of 8 and f of n. They do tell me it is geometric, and they give me f of 4 equals 216, and f of 3 equals 36. Okay, so remember our formula. F of n is equal to f of 1 times r to the n minus 1. I need to plug both of these points into that equation. So if I plug this point into that equation, I'm going to have 216 equals f of 1 times r to the what? 4 minus 1? Yes? What does 4 minus 1 end up being?
3.
So I have 216 equals f of 1 times r to the third. When I plug this one in, I get 36 equals f of 1 times r to the 3 minus 1, which ends up becoming 36 equals f of 1 times r to the second. Yes? The trick with these ones is you want the one with the higher exponent on top, because here's where we divide. 216 divided by 36 is 6. F of 1's cancel out, don't they? And what's r to the third over r squared? Isn't that just r? So I just found my r value. In order for my equation, I need r and I need f of 1. So how can I go find f of 1 now? Plug this back into either one of these two equations or the simplified versions of it. Doesn't matter. I'm going to plug it into the bottom one because it has smaller numbers. So 36 equals f of 1 times, I now know that r is 6, and 3 minus 1 is 2. So 36 equals f of 1 times, what's 6 squared? So what is f of 1? Divide by 36, and f of x equal, or f of 1 equals 1. So my final answer for my f of n is going to be f of 1 times r to the n minus 1. How would that really be written? You would really just see it written as 6 to the n minus 1. Okay. Now they ask me to find f of 8. So I'm going to plug in 6 to the 8 minus 1, which means that f of 8 is equal to 6 to the 7th. So what is f of 8 equal to? 279936 is my answer there. So? All right. 33. 33, 34, 35. I think I can do on here. I'll do it on paper just so it's all together. 33, 34, and 35. We're just identifying, is it arithmetic, geometric, or neither? Negative 18, 54, negative 162. And we want to know, is it arithmetic, geometric, or neither? Same thing with 34. Arithmetic, geometric, or neither. And 35, negative 12, negative 2, 8, 18, 28, arithmetic, geometric, or neither. Now, if it's arithmetic, I know that they're adding the same thing each time, right? You cannot be adding the same thing each time and be going back and forth between negative and positive. So I know this one is not arithmetic. Is this one arithmetic? Are they adding the same thing each time?
No.
Plus 1, plus 4, not arithmetic. What about this one? Plus 10, plus 10, plus 10. This one is arithmetic, which means it's not either of those two. Okay? Geometric, I take the second term, divide it by the first term. I get negative 3. If I take the third term, and I divide it by the second term, I get negative 3. If I take the fourth term, divide it by the third term, I get negative 3. Is the same true if I take the fifth term and divide it by the fourth term? That makes it geometric. Is this one, we know this one's not arithmetic, is it geometric? 2 over 1 is the second term divided by the first term. What about the third term divided by the second term? Those don't match, do they? So it can't be geometric, it has to be neither. So?
Wait, how'd you get 34?
Because I took 2 divided by 1, I did the same thing I did for the geometric. Second term divided by the first term, it reduces to 2. Third term divided by the second term doesn't reduce to 2. It reduces to 3. So if those two numbers don't match, then it can't be geometric. Geometric, it will always reduce to the same thing every time. Okay. 36. Find the recursive formula. So recursive formulas were these first two we wrote down. So I need to identify, is it arithmetic or geometric? This one, let me check arithmetic first. They are adding 8. Is that another 8? Yep. So we have arithmetic recursive. The formula for arithmetic recursive is, sorry, not A, f of n equals f of n minus 1 plus d. So what's my formula going to be here? F of n equals f of n minus 1 plus what? 8. You do also have to include in a recursive formula what f of 1 equals, in this case 25, because recursive formulas, you have to rely on that first term to get you started on it. Okay. 37, 2, 6, 18, 54. Definitely not arithmetic. 6 over 2 is 3, 18 over 6 is 3, 54 over 18 is 3. We have geometric. Our geometric recursive rule says f of n equals f of n minus 1 times r. So my recursive rule is f of n equals f of n minus 1 times 3. And again, because it's recursive, list f of 1, which in this case is 2. There's our quick review of our recursive ones. Okay. 38 says, evaluate the arithmetic series described. We have summation notation. We have m equals 1. We have 13 and 4m minus 6. Okay, so we have a sum. It does say in the directions that it's arithmetic. So there's my arithmetic one. That's the formula I'm going to be using. So S of n is equal to n times f of 1 plus f of n divided by 2. So my question is, if this is going from 1 to 13, what is my n value? N is going to be 13, all 13 terms. How do I find f of 1? I plug in 1. 4 times 1 is 4, minus 6 is negative 2. F of 1 is negative 2. When I have to find f of n, that means I find the last term. So I plug in f of 13, my upper boundary there. That would be 4 times 13 minus 6. 4 times 13 is 52, minus 6 is 46. So if I plug it all into the formula, S of n is equal to 13 times the first term, negative 2, oops, I don't need parentheses there, plus the last term, 46, divided by 2. So the sum of those 13 terms is 13 times negative 2 plus 46, divided all by 2. I get 286 as my answer. Okay. 39 says, again, sigma notation, it says it's a geometric series. It says n equals 1 on the bottom. What does it say on the top? 7. And I have negative 4 times negative 6 to the n minus 1. So let's see. I'm doing my sum of my geometric, which is this guy.